Welcome. This is Pre-Calculus B, Unit 1, Introduction to Trigonometry, Lesson 5, Special Right Triangles. You've learned about special right triangles, particularly the 45-45 right triangle, which I like to call the half a grilled cheese sandwich, and the 30-60-90, which is actually half of an equilateral triangle. As special triangles, you particularly learned about them in geometry class, and you learned about them in Algebra 2. In this class, we're going to deal with them in both contexts here, and I want to give the reference triangles to you in a couple forms. And you need to memorize both of them. So first, in geometry, you learned that in a 45-45 right triangle, the side lengths, if the legs are 1, the hypotenuse is √2. Okay? And what's more, if you happen to know the leg of a right triangle, you can use this triangle to find the hypotenuse, particularly by multiplying by square root 2, because to get from 1 to √2, you multiply √2. If you happen to know the hypotenuse of a right triangle, a 45-45 right triangle, and you want to know the leg, the length of the side, you divide by square root 2. Okay? Quick and simple example here. You have a 45-45 right triangle with a hypotenuse of 15. Then the leg is 15 divided √2, or multiply √2 over 2, or √2 over √2 on top and bottom to rationalize the denominator. You get 15 √2 over 2. Okay. Likewise, if you have a 45-45 right triangle and you know the leg is 15, then you know the hypotenuse is 15 √2. Okay, so that. Now, that is not typically the form that we have it in here in our class, because we're dealing with unit circles very often. And in unit circles, the hypotenuse is 1. So if I divide everything by √2, √2 divided by √2 is 1. 1 divided by √2 is irrational, or it's got to need to rationalize the denominator. So multiply by √2 over √2, and you get √2 over 2. Okay, so in geometry, we learned it as 1, 1, √2. In this class, we're going to deal with it more often as 1 and √2 over 2 and √2 over 2. Okay. All right. The 30-60-90 in your geometry class, you probably learned this way: 1, 2, square root 3. Right? And you learned to solve triangles using this ratio. If you know the short leg of a 30-60-90, to find the hypotenuse, you double it, you multiply by 2. If you have the hypotenuse and want the short leg, you divide by 2. If you have the short leg and want the long leg, you multiply √3. If you have the long leg and want the short leg, you divide √3. To give you a quick and simple example here, if we know the hypotenuse is 15, then the leg, I would divide by 2. The short leg is 15 divided by 2. And the long leg is 15 divided by 2 times √3. Okay? So all those relationships are used to solve right triangles, 30-60-90 right triangles. But again, we're dealing with unit circles, so we need a right triangle in which the hypotenuse is 1. So let's see what we get here when we do that. 2 divided by 2 is 1. Let's divide them all by 2. 1 divided by 2 is 1/2, and √3 divided by 2. So the sides become, keeping the same proportion. I've run out of undos here. The hypotenuse becomes 1. The short leg becomes 1/2, and the long leg becomes √3 over 2. Now, how do we use that? Well, we use that to evaluate trig functions. And I've probably jumped the gun because I think, as I recall, I actually did some of this already. But let's say we have the unit circle. And let me draw a circle here. And we want to find a trig function here on the unit circle. And let's say we use the angle let's do pi. Let's do 5 pi over 6. 5 pi over 6. Okay, so this angle is 5 pi over 6, which is 6 pi over 6 would be pi. It would be 180 degrees. The reference angle down here is 30 degrees, or pi over 6, right? So we know to use, I'm going to use degrees here just to link it to this one. We know this is a 30, 60, 90 triangle. The hypotenuse is 1, so the short leg is 1/2, and the long leg is root 3 over 2. Now this being on the left side is negative root 3 over 2. So I can safely say that sine of 5 pi over 6 equals 1/2. Cosine of 5 pi over 6 equals negative root 3 over 2. Tangent of 5 pi over 6 equals opposite over adjacent. That's 1/2 divided by square root 3 over 2, negative. 2's cancel. We get negative 1 over root 3. Rationalize the denominator. We get negative root 3 over 3. Okay? And I can find all the reciprocal functions as well. Cosecant is reciprocal of sine. 5 pi over 6 is 2. Secant is the reciprocal of cosine of 5 pi over 2 is going to be negative 2 over root 3. Rationalize the denominator, negative 2 root 3 over 3. And cotangent is going to be the reciprocal of tangent. 5 pi over 2 is going to be root 3. Okay, so that's how it's applied, and those are the reference triangles.